All right, we are going to divide some rational expressions. If you've watched the multiplying rational expressions video, this is very similar to that. There's just basically one additional step. So here's some steps, and let me go ahead and just do this example, and I'll kind of refer back to the steps as I go along. So yeah, you just want to factor like crazy at first. Just factor everything in the numerators and denominators. I notice this is a difference of squares, so this is going to come out to x minus 2 times x plus 2. All right, here's the formula if you like the formula. Okay. And then this is over 8x divided by x plus 2 over 2x. Can't factor anything else. You want to identify excluded values at this point because we have, well, anytime you have denominators, so you got to think about what would make them 0. So x cannot equal 0 is actually the only excluded value, right? If you put 0 in here or here, you're going to get 0 on the denominator. It would not be like negative 8, right? 8 times negative 8 is not 0. 8 times negative 8 is negative 64. So just be careful there. You only do opposites when you have addition or subtraction, right, involved. All right, now what we do, the new step is just like you would a regular numerical fraction, a fraction just with numbers in it, you keep, here's my little way to remember this, keep, change, turn. You keep the first fraction, you change the division to multiplication, and then you turn or flip the second fraction. What you're doing here is multiplying by the reciprocal. That's a way to always divide something. You can multiply by the reciprocal. Now you have to go through and think about, do we have any more excluded values? Really all that changed is the second fraction. We already have the 0 here. I'm just going to say x does not equal negative 2. That's a new excluded value we have. So that's another additional step on these dividing problems. All right. Okay, now we're going to cancel or cross cancel. I notice these x plus 2's can cancel. I notice the x's can cancel. And that looks like about it for now. Yeah, I'll do this the long way. If I were just doing this on my own, I would probably do some canceling there too, but I want to make sure everybody can see this. So let me rewrite it out like this first. And yeah, I notice 2 over 8, that reduces to 1/4, which, this is one way of showing it like that, okay? And now this just comes out to x minus 2 over 4. And now we have to list out all our excluded values, any that we had in throughout the work here. So you can just do this, all right? Okay, so that's how that works. Let's do another one, number 6. First one here. So factor like crazy. If you watched the other video, the multiplying rational expressions video, these are actually pretty much the same problems, just these are division symbols instead. So the factoring is going to be very similar. Two numbers that multiply to negative 8, add to 2, well, that's going to be negative 4 and positive 2. Here, two numbers that multiply to negative 10 and add to negative 3, well, that's going to be negative 5 and positive 2. So it'll look like that. Two numbers that multiply to 6 and add to 5, that's 3 and 2. Now you want to make sure you identify excluded values before you start canceling like crazy. It's really tempting to want to do that. Oh, I see things I can cancel. I really want to get rid of those. But no, identify those excluded values first. So I have 4, right, because 4 minus 4 would be 0, negative 2 from this, negative 3, and then I have negative 2 again. You don't need to write it twice. Now, it's kind of like, since these are in the same fraction, you could cancel these out, but I would avoid doing that. You can't cross-cancel here. That's a big error that can be made. Like, you can't cancel that with that because this is not multiplication yet, all right? So I would resist that temptation to cancel until you sort of convert this over to multiplication. And to do that, again, that's step 3 over there. You keep the first fraction, change the symbol to, change the operation to multiplication, and then you flip this fraction. So we'll have x plus 3 times x plus 2 in the numerator, and x minus 5 times x plus 2 in the denominator. Now we can go ahead and freely cancel here. And I guess that's all I could have done anyway, but that's all right. Yeah, just for safety, just in case, you should always convert to multiplication first before you start canceling. Also, one thing I should have done before I canceled those, that was a little bit of a mistake on my part. I should have identified any additional excluded values. You're only going to have any additional in this second fraction. This one's the same, right? So we 5 x cannot equal, and then -2, which I actually already had. I mean, I'll write that down, but I already have it. Okay, so yeah, I should have done that before I canceled that. All right, and now we just put these two pieces together. Meaning we're multiplying them, which we're just putting the factors right next to each other. You don't need to actually multiply anything out. You don't need to like distribute that 3x squared in. Yeah, you don't need to do that. So it depends on like what we were doing next. If this were in a, depends on the context, which we don't really have any context here. So this is fine. And now you just list out all your excluded values. You don't have to do an order if that bugs you. You can certainly do it in order. I'm just going to do this. Don't write that -2 down twice. All right, and I'm just going to kind of double check. Did I miss anything that can be canceled? Nope, doesn't look like it. So there we go. All right, one more example, and then I'll let you guys go for it. Here is a very similar problem if you watched the other video. So I can factor the numerator here. I can take out an x. And I end up with that, right? X times x is x squared. X times 8 is 8x. As a trinomial, two numbers that multiply to 15 and add to 8, well, that'd be 3 and 5. And then the numerator on the second fraction, can't do anything. The denominator here, you can take out a 7. 7 times x would be 7x. 7 times 5 would be 35. Identify those excluded values. X cannot equal -3 or -5, and then there would be -5 here also. Don't need to write it down again. All right, now we do the keep, change, turn step. We sort of convert this into multiplication. So we keep the first fraction, change the symbol, and then rewrite the second fraction as its reciprocal. We flip it. Identify any more excluded values. We're going to have -8 also, right? From that second fraction, it has a new denominator now. Now we just start canceling. Boom, 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 boom. You can cross cancel at this point, right? You can't cross cancel here, but you can here. All right, I think that's all we can do. We can't cancel that x and that x because this x is involved in addition. So we'll have 7x over x plus 3, and then we just list out all of our excluded values. So -3, -5, -8. X cannot equal those. All right, you guys go ahead and do numbers 7 and 8. Okay, on number 7, I got 2x as my answer. A lot of things cancel out here, and then my excluded values are -4 and 3. There were no additional excluded values on that step after you keep, change, turn, so that's why I drew that little line there just to show you guys that. You don't have to do that, but all right, so that's that. Don't forget, of course, if you have something over 1, well, anything divided by 1 is just that anything, just that itself, right? All right, number 8, I factored, identified my excluded values. And then I flipped the second fraction. There were no additional excluded values because this x minus 4 here ended up in this x minus 4 ended up in the denominator, but I already had 4 as an excluded value. You could have written it down, I suppose, but I saw that I already had it, so I didn't worry about it. And then you cancel like crazy. One question might be, hey, what if you cancel out this x minus 4 with this x minus 4? That'd be fine, because then this one would be left, and that would be in your answer. You get the same answer either way. Now, of course, you can only cancel, you can't say, like, this cancels with both of those, right? If you cross out 1 in the denominator, you can only cross out 1 on the numerator, or vice versa. All right, so we end up with this as our answer. And, yeah, bring our excluded values down. All right.